Welcome everyone. Hi, welcome everyone. So now we are in the lecture of numerical methods. So this is the second half of the semester. So when we learn about numerical methods, what we have to know is that numerical method is a techniques where you approximate on evaluating some functions, some values. So of course, when you have approximations, means that is not an exact solutions. Approximations allow you to have error, so you need to know how you want to express the error, and you need to know the confidence level of that error as well. So for today's lecture, we're going to learn on the error. So when we learn on the error, right, what you need to know is you need to know what is significant figures. You also need to know accuracy and precisions, and also some error definitions. Okay, right. So what exactly is significant figures? So significant figures is significant digits, right, of a number. So it is actually focusing on a number, those that can be used with confidence. So it corresponds to the number of certain digits plus one estimated digits. All right. So significant figures is a number where you have a combinations of digits that you are certain the value is, and also one estimated digits. Say for example, you have a speedometer like this. So say, look at this speedometer. The driver is traveling at, the car is traveling at about, we'll say like you see here, it's about 48 to 49, but it is not yet 49, but you are sure that it is traveling at the 48 at least. Yeah, so it could be 48.9, and it could be 48.8, and it also can be 48.7. So you'll see here that these two digits are the digits that we are certain. Yeah, but the digits that we are not certain is this one, 9, 8 and 7. Okay, so looking at this, we have two certain digits which are 48, but 0.9, 0.8 are those the numbers that is not certain or uncertain. Therefore, this figure is a combination of two certain digits and one uncertain digits. So that's gonna be three significant digits. All right. Let's say you have this odometer, and this car has traveled for about 87,324 0.4, right? But it is not yet 0.5. Okay, if you look at this, so the car is traveling slightly less than 87,324.5 kilometers, whereby it can be like 87,324.49. You can say that it is 80,324.48, or it can be 80,324.47. So you'll see here that these are six certain digits that you have. Sorry, here, these are the six certain digits that you have, and this at the back here, 9, 8, 7 are those that are uncertain. Yeah, so it's a combination of six certain digits plus one uncertain digits. So therefore, it's going to be 7 significant digits. All right. So how about 0? Okay, but for 0, it's slightly different. 0 is not always significant figure because they may be necessary just to locate the decimal points. So if you look at this one, although that you have all this 0 in here, you have all 0 in here, okay, but it is still these 4 digits the significant. Same thing goes to here and here. So all this is 4 significant digits, right? But when trailing zeros are used in large number, not clearly how many zeros are significant. So for example, we have 45,300. Okay, so this number of significance is depending on how you represent it. Like for 4.53 times 10 to the power of 4, so it's known to 3 digits because we are representing 3 digits in here. Like if we have 4.530 times 10 to the power of 4, this is known to 4 digits because we are representing it in 4 digits in here. So this one is 5 digits that we represent. It's known to 5 figures, so it's going to be 5 significant digits. So it depending if 0 is known with confidence, right? So how about accuracy? Accuracy, these are the figure that I've got from the textbooks. So here, accuracy is referring to how close the computed or measured value agrees with the true values, while for precision is how closely the individual computed or measured values agree with each other. Okay, so when you look at here, these two, the first dot that you have in here has low accuracy and low precision, while for this one it is higher accuracy, it's close to the true value, but still low precision because it is very dense for this one. If you look at it here, those marks are very close to each other, so it is higher precision but not close to the true value, so it is lower accuracy. But for this one, this is both close to the true value, which is higher accuracy, and those points are all close to each other, so it is increased precision, higher precisions for this one. Okay, now let's move on to error definitions. So for error definitions, you need to know two errors: truncation error and round off error. Okay, so truncation error is resulted when approximations are used to represent exact mathematical procedures. So meaning that you approximate it to represent exact mathematical procedure. For round off error, it is resulted when number having limited significant figures are used to represent exact numbers. Okay, so never mind, I'll go this one further later on. So of course you have true value. Okay, so true value is equal to approximation plus error, or you can have in other terms, you can also represent it as this one. True error is equal to true value minus approximation. So approximation is those that you are using the numerical methods, and true value is sometimes we use the exact method. So in here, we always use like calculus and all. You need to know true fractional relative error and also true percent relative error, just like this one, where you can have it in the notes. Okay. Right, move on. Computer representation of numbers. You need to know the number systems whereby computer always store our numbers, everything's all in binary numbers. And also those that are very familiar to us are decimal numbers. And you need to know on how to represent floating points. So in other words, how to determine these floating point representations. All right. Okay, so thank you very much. We'll stop here.